All right, so let's go over some problems on this. All right, we're going to find the critical value TC with a given confidence level and sample size. We're actually not going to use the table. We're going to go ahead and use Excel. So once we know that n is 11, remember that means our degree of freedom is 11 minus 1 or 10. Okay, so our C of 0.9 would mean that our probability is 0.10. Okay, so if I go and bring up some Excel here, and if I do equals t in to tail, and I put in 0.10, I put in 10, and I get we'll call it 1.812. Okay. Now this time we're going to find the margin of error. So we're going to need the critical value and then some more to find the E. All right, so again, let's look at what we have. We have a confidence level of 0.98. Again, that's going to be a probability of 0.02 when we go and use Excel. And we have n of 10, so we have a degree of freedom of 1 less, so 9. All right, so then we know that our margin of error is our critical value times s over the square root of n. So we need this critical value here. So we'll go back and get Excel. Let's get rid of that. So t inverse two-tailed. We said a probability of 0.02. We said a degrees of freedom of 9. And so we get 2.821. This is 2.821. So we get 2.821 times s is 5 over the square root of 10. Remember, we're using actually n there, not the degrees of freedom. And this comes out to about 4.5. All right, in this one, we have a few more steps. So we're going to have to find the critical t-value. We're going to have to find the margin of error, and then we're going to build the interval. Okay, so the C 99% confidence, again, that's going to give us a probability of 0.01. They've given us the X bar, they've given us N, S, and they've given us N, which will tell our degrees of freedom is 1 less is 9. Okay, so again, I'm going to go ahead and put my formula for my margin of error, TCS over the square root of n. I'm going to have to go get that critical t value. So let's see. We have equals t inverse two-tail. So 0.01 probability and degrees of freedom 9. And so we get 3.250. All right, so we'd have 3.250 times s, which is 4.0 over the square root of 10. And that's going to give us about 4.1. Okay, so that's the margin of error. So now all we need to do is we need to take X bar, subtract that margin of error, take X bar and add that margin of error. So they told us X bar was 13.4. So I'm going to subtract 4.1 and I'm going to add 4.1. When I subtract, I get 9.3. When I add, I get 17.5. And so this would give me 9.3 to 17.5 as my confidence interval. Okay, so now we just have to pull the information out of what's given here. In a random sample of 29 people, so n is 29, the mean commute work time was 34.1 minutes. That's the sample mean, x bar, 34.1. And the standard deviation was 7.3 minutes. That's the standard deviation coming from this sample. So we have S as 7.3. Assume the population is normally distributed. Good, that means we can do this. Use a t-distribution to construct a 95% confidence interval. So C is 0.95. All right, so again, we're going to need to go and build the margin of error using a looked up critical t-value, and then build that into our confidence interval. All right, so this C of 0.95, again, that's going to be a probability of 0.05. Our N of 29 is going to be a degrees of freedom of 28. Okay, so I'm doing E as the critical t-value times S over the square root of N. I have to go get this critical t-value. Equals t inverse, 2t, two-tailed. What did we say? We said 0.05, and we said 28, giving us 2.048. This is 2.048. So we would have 2.048 times S was 7.3 over square root of 29. All right, and this is going to end up, this whole thing is going to end up to being approximately 2.8. So then we're going to take that 2.8, and we're going to take x bar minus e, x bar plus e. So we have 34.1 minus 2.8 and 34.1 plus 2.8, giving us 31.3 and 36.9, and that's our interval. And we had found that our margin of error was about 2.8. All right, and that means that with 95% confidence, it can be said the population mean commute time is between the bounds of the interval given.